Uh, Thank you. So just know that we are recording this, and we'll send the slides and the recording to everybody that's registered. Dave, it's so great having you back. He's done several of these workshops for us, and he's done a wealth of sustainability work and geothermal, and now it's all about electrification. So take it away.
All right. Well, thank you everybody for taking some time out of your evening. We're going to talk about heat pumps for new homes. You can read that when you get the deck. We're going to do, actually, there's a lot of material. I have 150 slides. No, I really have about 30 slides, about 30 minutes. And Tim's going to talk about heat pump water heaters. So we're going to try to give you lots of information tonight. We're going to go through about heat pumps real quick. Then we're going to get into strategies for new homes, costs, and how do you actually go about the process of getting a good heat pump, getting a good system. So for those of you, probably everyone might know, but for those of you who don't know, the heat pumps is basically a two-way air conditioner. And you want to think about, everyone gets confused because they say, oh, if it's cold out, how does it keep my house warm? It moves heat, not temperature. So think of it as a concentrator of heat, not of temperature. So really, it's pretty, this is just a basic inside this outside unit here. Here's a couple of looks at outside unit. Looks like there's a coil in here, and it goes around, the fan blows the air by it. And it has refrigerant. Refrigerant is kind of the magic of all this. It has the properties of very much liking to absorb and give up heat at low temperatures and high temperatures. It absorbs it, it becomes a gas. It's not quite warm enough to heat your house because, you know, it's concentrating as much heat as possible. Comes in, this is where we need a little energy. There's a compressor in here, and I'll talk more about that later. That compresses it, it makes into a warm gas, which goes through the lines to an indoor unit. Inside there, there's coils, air blows by that, and the air absorbs the heat, and it goes out into your house and warms your house, and it comes back. One thing to note about this, a little bit different than the furnace, people will notice when they get the heat pump, this gas in here is about 100 to 110 degrees. So when the air comes out of a vent or these units, it's not going to be super hot. It's going to be in the upper 90s. So you put your hand over, it feels kind of neutral, but yet remember, we're only trying to heat the house to 72. So it's plenty enough heat, but just that's some notable differences some folks will notice. So the part of the reason that I'm even able to be here is just the dramatic improvements. In the early part of this century, we wouldn't even be able to have this talk. And so what it is, it's called cold climate heat pump technology. And they've been working in Japan and Europe for quite a while, but around the early part of the century, I'm saying roughly 2005, I'm calling it, you know, to create a story, the birth of cold climate heat pumps. And there's a lot of efforts in looking at how do we defrost them? How do we get them to work when it's really cold, the capacity, the ability to heat houses. And they were very effective. And we'll talk a little bit about what the magic is. And from 2012 to present day, they've been installed all throughout North America in cold climates, New England, Midwest, Canada. So they're out there by the tens of thousands working really well. Well, the engineers, when they got this task, there was a lot of stuff they could do. Inverter-driven scroll compressors. So basically in the past, the compressor was kind of on-off. Think of it that way, on-off. But now these scroll compressors, or the computer controls, they can give you as much heat as you need and only as much heat as you need, saving lots of energy there. You had to have defrosting because when it's icy and 30 degrees, you can't have this heat pump stop working. Then you looked at the heat exchangers that I talked about on the previous slide, making them thinner, making the heat exchange better, making the fans work better. And then one of the big things is really computer controls, which means this outdoor unit, this compressor that's actually using a little energy to heat that refrigerant up, only putting so much energy in. Well, the indoor unit isn't, you don't want to turn the fan on full blast when the compressor is only doing a little bit. So the modulate works together as a system. So what did that do? Well, a couple of huge things. One is Here's outdoor temperature on the bottom scale from 0 to 70. And this is how much heating a house uses. And we'll define that later. Just think of it, the higher number, the more. And this green line is how much energy it takes or heat to keep your home at 70 degrees. Well, in the past, this little blue line is how much heat these old style classic heat pumps could put out. And they weren't really designed to work in cold climates. So at about 30 degrees, I could put out as much as I need. But basically, over time, all this improvements, now it moves it up, and this orange line is how much heating capacity a unit can do. And so if it can do this much at 50 degrees, they can maintain it all the way down to 0, and it falls off a little bit, but basically holding a lot of capacity. So this big yellow area, in the past, the technology couldn't do, now it can do it. You still have a little bit up here, but it's a very small amount. And basically there's a little electrical in there that supplements, or in some cases you could have an old gas furnace or something to supplement. So this is number one, really the ability to do all this heating. Number two was amazing efficiency gains. And this is really neat because honestly, about every 2 years, the manufacturers can up the efficiency a bit. And this is 0 to 14. HSPF is another standard of efficiency where 8 is double 4, etc. So back about 2012, a lot of the units were around 8. Now these cold climate heat pumps are in the range of 10 to 11. If you go out, most all of them are in this range, which is a 28% increase over the last dozen years. In fact, 2020, the biggest is 13. We're in 2022. We're still right about this technology level. So I would expect in 3 years, we might have another point or two jump, but think of it, 30% improved. So what's happened? Here's what's going, the summary is we have improved efficiencies. We have the ability to defrost. We have the ability to heat below 0, and we have the capacities and the efficiencies in that little triangle to heat your house when it's between 0 and 30, which is most of the winter months. So we're going to talk now about basically there's sort of 2 mega categories of heat pumps. One is, well, this is the one, this is called whole house with ducted systems. And basically you have 2 configurations. You've got an outside unit, looks like an air conditioner, and it goes to an inside unit. This is with an air handler. So this looks like a furnace, but it doesn't have any burner in it. It has a little bit of electric heating coil for that little bit of extra it might need. But these are the 2 units. You can also pair these, the heat pump, the outside unit with the furnace, but you're using, really in that case, you're really using this furnace as a blower and a smart indoor unit. In the case where you need to make up that little triangle, it has the capability to provide extra heating in that case too. So that's sort of the whole house ducted units. The other thing, which is even more of a revolution, is multi-spoon. They're called mini split or ductless. And I think I've been around for a while, but basically originally it was these units that go on the walls. A lot of people have seen them advertised in an outdoor unit. And, you know, each of these units, you can put several on one of these. It doesn't take much room to run these through the house, so you don't have a lot of ducts. And they're very quiet, lots of styles. But let's talk a little bit more about that. And this is what's kind of really exciting for you as a homeowner, architect, builder, and even HVAC guy. It gives you a lot more flexibility depending on your home. So there's many different units, the original wall units, and some now they make them really slick, artistic designs. There's these kind of low wall units for those rooms that you have that, and that makes sense. But these are also 2, then sort of the 2 next big improvements are these really recessed ceilings. These are very flexible. There's 2 styles. One is kind of blows all directions. It can really sort of maneuver the fans. The air can go high, it can go low, very sophisticated. These here are also very nice. They go kind of around the edges of the perimeter of the room and blow across. So really think of these as a nice alternative to these strategies. So you've got these, but then you also have these slim ducted units, which are only about 9-10 inches, and you can duct and have just a grill. And the nice thing about these is you can work a couple of rooms off of one of these units. You can tuck them above closets, above laundry rooms, etc. And then finally, a couple of the manufacturers now have in combo with all of these a big air handler. So literally you can do several rooms or a floor with the duct system, but you can combine it with one of these for other rooms. And we'll talk about that a little bit more later. I need to talk about fresh air systems. And it's very important now because with a new house, you're going to want to build a really well-constructed house, very tight, no leakage, lots of insulation, but you really need fresh air. In the past, it was like, well, we just open the windows. We still do that when it's nice out, but when it's super cold or super hot, or unfortunately, when we have lots of smoke, that's not really a viable option. And even for the basement, it's not often you're going to need this in, especially. So it's called a heat recovery ventilation system. And the way it is it brings fresh air in, but it doesn't lose the heating or much of it that you've already done. And it's usually integrated ducts, but if there's no ducting, you can integrate it other ways. And this is just a little diagram to show you kind of how it works. So think of it this way. This air coming in from the outdoors, it might be, say, 40 degrees, and it's going to come in. And in this box, which is about usually maybe 20 inches by 9 inches by 12 roughly, it's going to come in and exchange with some air that's from the inside exhaust, from the returned air or from a room, goes out, and in this exchanger, it exchanges heat. So now this comes out of here, it might be 40 here, might be upper 50s here, comes in, gets heated a little bit and goes to your house. So you're saving all the heat, or in the summer cooling. So these are going to be systems that most of your contractors are going to be putting in conjunction with whatever system you have. Very important. So now we've got all these tools, whereas in the past you just didn't have these options, which is great. But I'm trying tonight to make it not too hard, because it's not infinite options, but you first have to really think about what you want. So, okay, we're going to try to get comfort in all sections of your home. Where do you want cooling? Down in the Front Range, other parts of Colorado are really hot. It's like everywhere, every room. But in the high country, you might not really need it in all the rooms. Talked about fresh air. Radiant in-floor is often a priority up there, but I'll talk about some combo where you might want to say, do I really need radiant in every room? Does it make sense if I've got these great other systems that can do it? And how important it is reducing or eliminating emissions if you're going to have some gas as part of it or none. So those are the things you want to think about. Let's think about them in a more specific way. So really what you want to say is, okay, how many thermostats do I want in my house? The old 50s, 60s houses, it was like one. Even my house is in the 60s, one thermostat, wasn't very comfortable. I'd say you really want at least one for each floor. You might want a second for the master bedroom. Looking at the main floor, there's usually a sunny half, not so sunny half. It might be north, south, east, west, or you might do the great rooms. And the basement, generally the basement is pretty consistent and it's super well insulated. It hardly needs any heating or cooling. I mean, very little at all. But if you've got a lot of, I call it use diversity, where you're going to have a finished basement with a bedroom versus a TV room versus a laundry room versus a workout room, and I have one current client that's doing this, then you might want to think about little bits of supplemental in certain rooms. Where do you want your cooling? Similar questions. Do you want no cooling, like, whole house, second floor? And where's radiant heating important? The whole house, is it the main floor? Second floor, do you want just, the master? Do the auxiliary bedrooms need radiant heating or not? So these are the kind of questions you want to be thinking about. So you're thinking about all those questions and you say, well, okay, what's the strategy? And I'm going to say that we're talking about heat pump centric strategies because that's really where things are now with the technology. The old day of thinking, okay, my my heating system is going to be like a furnace and air conditioner, a boiler and air conditioner, or really going in the way of my heating system is going to be a heat pump. And so let's think of it in that context. So I'm going to say we got whole house ducted heating systems. And we're going to go into these a tiny bit more depth in the next slides. But okay, so cooling's automatic and cooling. It's easy to add filtering and fresh air. Because it's all these big duct systems, it's more difficult to have many zones. And you're going to have either no emissions from your house into the neighborhood, or very low if you have a furnace with it as a little bit of the backup. So you've got lowest or second lowest GHG pollution scenario. The middle one is whole house multi-zone mini split heat pump system. So think of this one, but actually adding a little more flexibility. So you've also got heating and cooling and filtering included. Depending on the setup, adding fresh air is going to be a little different. Some places just adds it to the ducts. Other places it might be mixed in with like the bathroom fans or something. You've got more zoning flexibility. It's all heat pumps. So you've got, no pollution or no GHGs. Combo number 3 is going to combine, you want radiant. You're up in the mountains, you want the comfort, but you also want the cooling, you want fresh air, and you do want to lower your energy use by a lot. So you're going to do this combo system with these mini splits and the radiant. And you're going to have, when the mini splits, they're going to do the full cooling and filtering. You're going to have a different fresh air system. You got maximum zoning flexibility, and you've also got some flexibility on how you're doing the heating. How much do you want to use the heat pumps? How much do you want to use the radiant? And we'll talk a bit about that in some of the next slides. So that's kind of the third general strategy. So let's talk about strategy 1. On a 1-level home, it's pretty simple. That's what I showed before. You've got one outdoor unit, one indoor unit. You've got your ducts. You can add filtering and you can add heat recovery right in it in the basement. But you want to talk to the builder and make sure you're going to want to zone this, because like I said before, you're going to probably want 2 zones, sunny side, cool side, or kind of main rooms, bedroom, wing, etc. However, and so you want to sort of, when you're talking with your builder and the HVAC contractor, ask them, how are the ducts going to go? Does it make sense? Because you're going to just have a little zoning in the ducts, little damper controls. Or how are they setting it up? Pretty straightforward setup. Let's talk about the basement really briefly, and this is true in general. You really, in the past, they'd have like 3 or 4 vents into the basement. You barely, like I said, you barely need any heat or cooling in there, but you do want a little bit of venting for fresh air. For that, and and we'll talk a little bit more basement and some of the other options. If you got 2-level home, now in the past it'd be do the same thing and then run vertical ducts to the attic and then do that. You can still do that, but you really want to have zoning, and you want to have a zone damper for the verticals. It will still work. I would claim it doesn't work very well generally in comfort and in efficiency, because you're going to lose efficiency because you got to have one big unit here, whereas doing 2 heat pump systems, generally the second floor is much smaller with loads, so you can have a smaller system, higher efficiency, and then you've got one down here, and you don't have all these vertical, the verticals running up through it. So that's kind of a good strategy, and you can have 1 to 2 zones per floor. So you're going to maximize comfort, maximize efficiency. Similar story for the basement. So let's do what I'm calling the whole house mini split strategy. And so you've got some advantages over, still think the similar strategy, but there's a couple things you can do. One is, one outdoor unit can have multiple indoor units. So if I go back to this strategy, if the house size is small enough, meaning roughly 4 tons of load, talk about that later. You can have one of these units outside, you could have one of these units inside, you could have sort of one of those, you could have a mini duct up here and maybe a couple other units up here. So you could have literally like 2 systems off of 1 outdoor unit. That's possible. But really the other thing is you can add more zones. So in my second floor example before, I had 1 system for the whole area, but typically, let's say for the master bedroom, I want more control. So I can decide I can do a ceiling cassette in the master bedroom. I could do a wall mount. I could do something else. So now think of it as I've got this ability. I've got sort of 2 main systems, but I can add these specific units for specific rooms, or I could decide in the second floor, if it's only got 2 bedrooms, I don't need to build a duct system up there. I just use 2 of these units. So what you're doing is you're giving yourself the ability to add more comfort, a little more efficiency into the house. And so the final one is radiant. And what you want to think about here is you can think about now you're having a mini split strategy with radiant. One thing you might want to consider is the mini split is kind of the primary heating cooling system for the spring, summer, and fall. The reason is, and I'll show you in like 3 slides, in the spring, summer, and fall, the heat pumps are extremely efficient. And so they're even a higher efficiency. So you're really gaining a lot more heating with less energy use. And then you get into the winter and you still want the warm floors and you want the radiant feel of heating. This is kind of a balanced strategy. So how would this look in this house? I just put up something here. What might you think about in this house? So normally north is the top, but for the sake of this, let's call north the south the top. So I might look at this second floor and say, all right, I've got this, I'm gonna put radiant in the bathroom because you don't really, want to use all these mini splits for little room. I'm gonna put radiant in the bathroom. I don't really need to cool my bathroom. I'm gonna put radiant over in here. I'm gonna put radiant in my bedroom. And this here, I'm gonna put in this section here up in the attic, I'm gonna put a mini split system or even a straight one with, I'm gonna put a unit up here and I'm gonna duct these rooms and I'm gonna have cooling and fresh air. And then over here, I'm the owners, I'm going to do something. I'm going to do like a single wall unit or ceiling unit or something. So now in the owners section, I've got really optimal control in my bedroom. So you now have the choice. Do I really need to put radiant in these bedrooms or not? You can choose what you want to do. The heat pump's going to be plenty. It's going to heat and cool. I could do it all year round. Or you could say, okay, I will leave a little radiant in here. Maybe these are the kids' rooms in the winter. I want them to keep them warm, so I will do that, and I'll decide to use the heat pumps for the other parts of the year. So you've got all this decision and this flexibility. That's the beauty of it all. Let's look at the main floor. So in the main floor, I'm going to consider the mini split as the main for the rooms I want cooling. And so the non-ducted, the nice things is they offer flexibility in installing any rooms without expensive ducting. So realize in the main floor, sometimes it's a little bit harder to get ducts around and figure out what you want to do, especially if you don't have a basement under part of it. But for here, I'd look at this and say, well, okay, I have these areas here. I can have something underneath in the basement, but I could also put like I could put a unit up here and it would do this room. I could put then a unit over here, do this room. That gives me heating and cooling. South is up. Let's just say I've got the sunny side, the warm side. I've got my radiant in here. I decide to put a little unit in my home office. Maybe I say I want radiant in this whole area. Maybe I don't need it in the dining room, the home office. So you've got your choices and realize, every room that I choose to do one or the other, I'm saving significant money by not having to do redundant. So you've got these choices, and that's the kind of strategy you want. And let's see. Okay, I got to accelerate a little bit here. So what's the cost? to operate. So propane and gas, COP, the number, coefficient of performance, is how much units of energy do I get out for units of energy? Furnaces and boilers, 95% is 0.95. Electric heat is 1. Heat pumps are 3, average over a year. Now they range from say 2 to 4 over a season, just to give you an idea. It's a range. They only use 33% of the energy. Okay, versus electric systems, all electric, you're going to always save 65 to 70%, no matter what the price. Basically, propane's always been very expensive, similar savings. Gas, it's very interesting because realize what's happened in the last 10 years. Gas in the last couple of years, double in price. Heat pumps have gained 30% efficiency. Those two combos. So now you're going to save, if you use the radiant heat pump combo, you're going to save 5 to 15% versus all gas. And if you're going to go with all heat pump system, we're in this range where it's, let me say it's a tie, and it just depends. A bit more or a bit less, which is not a lot. If you use the low end of gas price last December excels, it's gas a little bit less. If you use the average Colorado price, gas would be more. If you use the higher end like Black Hills, it would be more. So for a typical home, this swing is 10 to 20 a month either way. So we're not. So basically, I'm saying we're tie. Everything's at parity. Now this just to show you here real quick, a little more touching on why heat pumps are so great at the 3-season deal. So in here, this is sort of the high and low in Eagle, 14 degrees, 35. So let's just start in March. Very simple. The COPs of heat pumps getting very high, over 3, cooling, over 3. And then they get a little bit less efficient. Still heating, still work great. But realize, if to most people this is a little bit counterintuitive, most of the heating, this is outdoor temperature from -15, 65, and this is the percent of the energy use. Almost all the heating use is above 15 degrees. So in this area below 5, it's only like 15% or 10% in here. So realize, man, during all this heat pumps, amazing efficiency. And so really what this is addressing is that when you do this kind of combo radiant heat pump system, you've got really some great choices, and you can look at this and not only you're not really going to compromise comfort, but you're also going to maximize efficiency. What about upfront cost? We've got so as Mary alluded to, in the last year, it's amazing what's going on now. This drive for heat pumps, electrification. So right now, starting in 2023, you're going to get about $7,000 for a heat pump system. Colorado is going to have a 10% tax credit on the equipment, which equipment, let's say 10,000 is 1,000. You're going to have a 30% federal tax credit up to 2,000. And then Holy Cross, you've got 25%, which is up to 4,000, which, you're going to hit that. So you've got almost, $7,000 for a heat pump system. The whole house ones are going to be sort of the lowest cost. Taking those and adding the mini split strategy, basically it's the ducted strategy, adding a few things here and there. So you're going to get, basically what you're paying for a little more comfort and efficiency. And the combo is the highest cost, but it's lower than the radiant AC ducted combo, because with the AC ducted, you're always forced to do ducting, where these mini splits, you have more flexibility and choices as to really what you want to do. And then so to give you, try to do an apples to apples. I mean, these systems are so customized, but to do an apples to apples, if you just say, I have a certain size furnace AC system, ducted cold climate heat pump system, equivalent quality. A lot of times you'll find that when you're talking to folks, it'll be like, well, premium heat pump, really low level other. So it's always, you want to get apples to apples. The heat pump system costs a little bit more, but with the rebates, it's basically lower cost at this point. So this is really this is really a kind of a tipping point. Let's go through a few slides, try to be quick here. I'm running, well, we started late, so I guess I still have a little time. These are some of the things we're going to talk about real quick, so let's get into it. So some of the things in the past, and I think this is really not happening as much anymore, because to get the rebates, Holy Cross and the other utilities are becoming, you need to meet the requirements. But in the past, people would not put cold climates in. They would not use manual J. I'll talk about that in a minute. That's the standard way. Even if it's not a heat pump, anything should be sized for your house. Maybe they didn't use the correct outdoor temperature for the climate zone. And you end up with these undersized units. One of the big things on the high country with air systems, you have to make sure you derate them, or in other words, because of thin air, you have to put bigger units in to get the same BTUs, and some installation problems. So if anyone's out there talking to folks and they say, oh, the heat pump didn't work, one of these things, it was a little more than expected. Typically, maybe it's undersized, so it's depending more on that auxiliary. That's A. How do you know you're getting a good system? You're going to work with your builder. They're gonna know a lot of this, but for you to know, it's got to have an HSPF. That's that efficiency. The higher number, the better. Cold climates are basically all 10 plus. It has this variable speed compressor. So if you're online looking at sites, that's a trigger point. It operates at low temperatures. Confirm with your builder and your contractor and your utility, or any of the references in the end slide, that's cold climate. And basically all the utilities now, Tri-State, Excel, Holy Cross, all the other ones, they have rebates. They've got pretty high levels of standard. If it meets those, it's pretty much cold climate. Here's some examples of, like, you're online, you're looking what's some of the brand names, make sure it's noisy, and talk about the warranty. Moving along, what size system do I need? I talked about manual J. So the builder, basically what happens is the contractor gets the builder's plans, and then they build a house in the computer and says, this is how much heating I need. And they'll put in the city. So Eagle is going to be very different than Grand Junction, than Edwards. It's going to say, your temperatures get down to this outdoor temperature. You have to have the ability to heat to that. And I will tell you, you probably don't have to worry about this, because most by default, HVAC guys have to be a little conservative. But if it turns out it's like between two sizes, you can go for the bigger one, because all these units now are very sophisticated and they modulate. Remember, I said they put out as much heat as they need. Here's some terms people will throw at you when you're talking to contractors and builders. They're going to say tons. What does tons mean? 12,000 BTUs per ton, BTU per hour. So 24 is 2 tons, etc. And you'll see in model numbers. So when you get quotes or you're looking through the builder's packet, you're going to see 02430 somewhere in this 20-digit model number. And that refers to the tons. So 24 is 24,000, 30, etc. And then this is sort of a rough guide to how many homes. And then for the mini splits, those get sized per the room, right? If you're going to just do 1 or 2 room, they have these little indoor units, same system, same model numbers. And so that's an important thing too, is sizing. And also the will make sure that this unit is big enough to work with however many of these units. Okay, 2 more to go. Selecting a contractor. And this, I should say, HVAC contractor. You're going to work with your builder. So, who else has built homes with heat pumps? New homes, and I'd say sort of similar size homes. If they've done an all radiant home with some heat pumps, and that's what you want to do, that's good. If they've done a ducted home, that's good. And ask what the HVAC contractors, talk to your builder. Who does he normally employ? Do they like to do heat pumps? Is there ones that he knows that are more into heat pumps? How many they install per month? The websites, etc. I'm not going to read through this because we're running short on time. Make sure the outdoor unit's done good. You don't want to have your unit covered in snow. There's a little bit about ducts. Make sure they're done really well. You can read these when you get it slides. Couple tips on mini splits. Summary. Basically, this is the new standard of way to do things. And it's not some newfangled thing. Like I said, heat pumps have been around a long time. They're all over the place. You know, you've got more options. Figure out your goals. What do you really want? What do you really want to do? You're going to get this presentation. You got some of the design, work with your builder, and talk with all the contacts after that. And I'm going to turn it over to Tim, who's going to tell us all about heat pump water.
Quickly, I just want to point out this page to everyone. This is your reference page when we send out the slides or you watch the recording on how to contact all your local nonprofits as well as Holy Cross Energy. And then the next page, I believe that Dave has on his, is another page. It's about loveelectric.org, which is also a really excellent resource when it comes to heat pumps and electrification. So please check those out.
There it is, right there.
Yeah. Okay. And Tim, we'll let you go ahead and share your slides and let you get started. Mary, do you want to introduce Tim at all?
Sure. So everybody, Tim's coming. Well, he's a Cardinal fan, so he's from St. Louis, and he's been with Rheem for 27 years. So if anybody knows heat pump water heaters, it's going to be Tim. And if you didn't get enough about heat pumps that can heat and cool your home, guess what? They can also heat your water. So thank you, Tim, for being with us, and we're really looking forward to hearing about this type of heat pump.
Well, thank you, Mary, and thank you, Nikki, and thanks for Walking Mountain as well as Holy Cross for inviting me here today. As Mary mentioned, I am direct from the factory. Actually, now I celebrated 28 years with Rheem. So for those of you that may not be familiar with Rheem, we are a global manufacturer of heating and cooling products, and we are by far the largest water heater manufacturer in the country. Okay, and we've seen the changes happening throughout the country, and there's a lot of things that we have done as a manufacturer in preparation for this. And our mantra is sustainability. So why heat pump water heaters? You know, I mean, Dave did a wonderful job of explaining heat pump technology as it relates to the home, but why a water heater? A water heater is the second highest energy user in the home, okay? In fact, it represents about 16% of all the energy used in the home. Now, compared to a standard electric water heater that typically just a resistor element water heater, a heat pump water heater is 300 to 400% payback versus a standard electric water heater. Let me explain what that means. Okay. Again, back to the Rheem. I mean, of the products we make, we represent 65% of all the energy used in a home. Okay. So let's talk about our new heat pump water heater and basically some of the things that we're challenged with. And, you know, we've been in business a very long time and we see barriers and we overcome those barriers, such as heat pump water heaters don't work in cold climate. Well, there's built-in thermistors that actually they will operate up until 37 degrees and as high as 145 degrees. They are utilized in a controlled environment. Okay, so these are in Colorado, you're not going to put these outside. Okay, it's too expensive. Dave touched on incentives. There are also significant incentives in your area and more to come. For those of you that are unfamiliar or have heard about heat pump water heaters, it's only 49 decibels. Now, what's 49 decibels? I'm probably speaking at 100 decibels right now. Okay, a heat pump water heater has to have 700 cubic feet of a conditioned space of air. Okay. And what it does, it repurposes existing heat. So the elements, if the unit is sized properly, really won't come on. That's where the heat's already there. We are one of the few countries in the world that haven't embraced this technology years ago. Okay. Now, we introduced this product called the Proterra back during the pandemic in 2020. And the expectations we've surpassed any expectation we could ever have had with this product in acceptance, to the point where we're actually expanding plants for the backlog and the demand. So let me tell you a little bit about the Proterra. Okay, we base it on a pillar, what we call the 3 SMART pillars, or the SMART, sustainable, and savings. So let's talk a little bit about SMART. Okay. We know in the water heater world that there's only two things that really cause concern. First is if there's leaking. Okay. Second, if it's not giving enough hot water, right? So we incorporated technology like leak guard, automatic shutoff, leak sense detection. These units have integrated what we call EcoNet Wi-Fi. Okay. These are connected products. The homeowner direct control of this product. Depending upon the utility, they may also have the ability to do that at your discretion. Remote control. Everybody's using their phones. You also get a free app from us that you can actually go online and connect your water heater to your phone. And of course, compressor and health element indicator. Basic, is your water heater healthy? The homeowner now will say, okay, my element possibly needs to be replaced, or I have a leak or something. Okay. And of course, hot water availability. This is my favorite, especially with if you have kids in the house. You don't want to be the last one in. You'll know not to go in. Now, another is sustainability. It is absolute highest efficient water heater in the country. Okay. Carbon footprint reduction. I think everyone is more aware of this now than ever before about climate change and awareness. Okay. This product is today to help. Energy usage tracking. Never before were you able to actually look on your phone and see how much energy your water heater is using, but this will show you. It also is Energy Star rated. That's a given. Now, of course, savings. That's why everybody's on here, right? Save money and energy. That's a given. Energy saving scheduling. Okay, you can actually schedule this unit to work in which type of mode to save the most energy possible, or replicate what your utility, how they operate in regard to rate scheduling. Demand response. Okay, it's more utility specific, but we can obviously talk about that later. And of course, vacation and away mode. You can actually turn this water heater off or actually drop it down to a lower temperature for almost a month. And then it will automatically go back on, or you can do it remotely from your phone. Now we have 3 models. So I'm going to throw them all up. Okay, I'm not going to go into specifics of these. However, we were the first to the market with a 40-gallon, and we go up to an 80-gallon. We have a builder model. We have the ProTerra flagship, and then we have the ProTerra with the leak guard and the leak sense right out of the box. Okay, but you can see if you're looking at this chart, you can see let's the middle one, ProTerra. Let me focus on that. Up to a 4.0 UEF, that's universal energy factor. For comparisons, a standard 6-year 50-gallon water heater is around a 0.92 to 0.93 UEF. A heat pump water heater in our 80-gallon is a 4.0. Okay, so that's significant. Up to $100 over the life of the heater, and the heaters do have a 10-year warranty on them. Now, how do you size one out? We made it about as simple can be. Okay, from a 40-gallon up to an 80-gallon, depending on how big the family is, but you got to use common sense on how often they're showering, as well as if a teenager's in there for 20 minutes, then you count them as 2. Now, this is where the rubber hits the road. Okay, this is what I would call our return on investment. I did a comparison in regards of a 50-gallon standard resistor element versus a 50-gallon hybrid heat pump water heater. The numbers you see on this slide are adjacent, or actually are comparable to what you have in your market, if not the same if you go online and check pricing. You can see that the initial investment for a 50-gallon hybrid is around $1,700. A standard resistor element is about $560. But that's not what's important. It's the annual operating cost. In this environment, you're looking at about $95 per year to operate a hybrid heat pump water heater versus a standard electric at $536. As I mentioned before, it has a 10-year warranty. So based on the savings, you're literally saving $4,400 annual, or over a 10-year period of time, or $441. So it literally pays for itself with the incentives and the rebates that are out there. And what I have listed on this is it's not all of them. Okay. So you may want to reach out to Walking Mountain or Holy Cross to have that verified. And then I do know that the federal tax credit was just re-upped for the remainder of the year as well. So this unit literally pays for itself in just over 9 months, just in the cost savings alone. Now, this is the energy guides. Any appliance you buy typically has electric going to it, you're going to see these. So these came right off the line of the plant. You can see the comparison of a standard electric versus this, this is a national, that's the energy, but you can see significant savings. Now, I went one step further. I actually took it down to gas as well. Okay, natural gas as well as. Dave made a comment about propane would apply to water heating just as much, and you can see that. It's pretty revealing. Now, what's important from a homeowner's perspective, okay, now you're connected to your water heater. Most everything you're getting now have some form of connectivity and control. Everybody's on their phones, right? Sustainability. Now, again, everybody's concerned about as they should be. And this product is a prime contributor to that. And of course, most efficient as well. Now, for those that are in the building community, this product, if you're familiar with HERS ratings, which could be a separate topic altogether, will improve your HERS score by 4 to 7 points. That's significant for any home builder out there or any homeowner that's looking to purchase a home. I would ask about homes that are HERS rated. Now, I'm giving you some visibility to what it would look like if you were standing in front of the water heater. You're just not using your app. You have a way of provisioning this unit as well. And I actually wanted to just focus on, you look at the left-hand corner, the current mode. This is the operating modes of the unit itself. The energy saver mode is the default mode. If the unit is sized properly, what will happen is that the heat pump will be the primary source of heating your water, and the elements won't even kick in. In the event you have a high demand where you have extra people taking longer showers, the elements will kick in, okay, but will not kick in together. They will always sequence back and forth, not to exceed 30 amp draw on your box. That's the default mode. No matter what mode you put this in, it will eventually work itself back to the energy saver mode, which ultimately is saving the homeowner money. Heat pump, provision it that way if you'd like, and the elements will not come in high demand electrification. The only thing that you really would have to do this water, we always wish that homeowners would flush these out if in hard water areas. Not anybody really does that. But the one thing you will need to do, though, it does have a filter in it, but it's a pliable filter. You need 6 inches of clearance at the very top. It is pliable, so you can actually bend it and pull it out, and you clean that out. Now, when do you do that? Well, the unit will tell you. It will tell you on your phone, or it'll give you an audible alarm on the unit itself. So again, it's a very smart water heater. EcoNet, I mentioned that earlier, right? Now, scheduling, usage reports, everything. I want you to focus more on the left-hand side, and let's dive into that. You can literally go in once the app is loaded and you hooked up with your heater, you can go in and change that 4 different times. You can put different modes. If you want a heat pump mode, you can change the temperature. Why do you do this? Because this is what utilities also look at in regards to the energy usage of going out and serving their customers. Okay, so you can actually provision this unit to save you the maximum amount of dollars. First thing I do is the usage report. I gave you the example. You can literally see how weekly, monthly, or yearly, how much energy you're using. This is what utilities look at as well. So you're getting what I would say a look under the hood in regards to your energy usage, so you can change your behaviors to save yourself additional money. Now, physical installation. Okay, if ducted. As I mentioned earlier, 700 cubic feet of conditioned space. If you have that, just pop the unit down, install it like you would a regular electric water heater, you're good to go. If you're limited, less than 700 cubic feet, you could literally duct these units. Let me give you an example, okay? You can bring air in, you can exhaust the air out. In Colorado, do not exhaust these outside, okay, or don't draw the air from outside. I mentioned earlier at 37 degrees, the heat pump will actually turn itself off. And I know you get well below 37 degrees, okay? You can go 125 feet. But NEA, which is a regulatory agency on the North or Pacific Northwest, found that less than 6% of people actually actually duct them, okay? But it is an option should you want to duct them. It is available to do so. And I had to throw this in, pat myself on the back as a company. We actually got the Green Innovation of the Year award, okay, from the Green Build Society, okay, in 2021. Now I have my email address. I'm sorry this was an abbreviated presentation, but Dave did such a wonderful job. He probably took 30 minutes off my presentation. So thank you, Dave. So feel free to reach out to me via email, or if you have questions in the chat box, I think we're all ready to answer them. Any remarks, Mary or Nikki?
Yeah.
Great.
Yeah.
Thanks so much, Tim. Much appreciated. That was a great quick presentation on your heat pump water heater technology there. Looks like we only have one question. If anybody else has any questions, please type them in that Q&A box, or you can go ahead and raise your hand, and I can allow you to talk if you prefer that. But the question we have is related to the new Inflation Reduction Act. What incentives are available to consumers or builders to incorporate air source heat pumps in new construction as part of the recent Inflation Reduction Act legislation? Let's say for a typical 4-ton system that might serve an average size 3-bed, 2-bath, single family home. So with this act being so new, I can maybe elaborate a little bit on this. The quick answer is we don't know yet. So there will be both tax credit incentives for anybody with a federal tax liability. And Mary did put a link to a great tax credit calculator in that chat box. So if you'd like, you can check that out. But in terms of rebates, those rebate programs will essentially need to be run through each state's energy office. And so the state energy offices will need to actually apply for the funding for the IRA, and then the Department of Energy will kind of hand down guidance on exactly how to use that funding for rebate programs. So there's more information to come on that. The general answer is that this is still in process, and we don't exactly know what type of rebates are going to be available through this specific legislation.
Mary, would you like to talk a minute about your new construction rebates for heat pumps
Sure.
and heat pump water heaters?
Sure. And I think that's a really good question about the Inflation Reduction Act. I'm not sure if it's going to handle new construction. I have used that calculator, and I was actually surprised putting in my income and my zip code. I was actually eligible for like $17,000 in tax credits. So go use that link. But that's a really good question. We need to dig in. Everybody's trying to dig into what this all means and waiting for the Colorado Energy Office to come back with some guidelines too. So for new construction, if you're a Holy Cross member and you don't bring in a gas line or propane, we will give you up to 25% of the project cost of $4,000 for any kind of heat pump. So air to water, air source heat pump. We don't have a lot of geothermal up here, but ground source heat pumps, we just don't see that a lot. And then up to $1,000 for the heat pump water heater. So Tim showed dramatically how the first cost can be a little shock, but if you look at the whole picture and the cost of over the life of that equipment, it's going to pay for itself in less than a year. And then if you go with induction, the cooktop, which so everybody loves to cook on gas, well, I would invite you to try cooking with induction. We give up to $100. And then a heat pump dryer. So there's even heat pump dryers, no venting needed, So we do up to $100 for that. So those are your 4 big appliances in your home. And then of course you talk to your builder about your breaker panel box. You know, are you going to need 200, 300, 400 amp? It all depends on those 4 big equipment uses. So
Just touch on the Inflation Reduction Act. I mean, the states are gonna manage and stuff, but it looks like sort of some of the outlines 30%, and I think the couple thousand is pretty conservative. I mean, the states will tweak it one way or the other, but those are sort of the guidelines, which correspond to like the solar guidelines of 30%. So,
Yeah, I think that 30% rebates related to kind of energy savings. And I believe it's more related to existing construction.
anyway, we'll see.
But yeah,
I know
Yeah.
Sweep's looking into that a lot, so.
yeah. And I will say it is income based. It's something that I was really impressed. Like Walking Mountains, you also offer. We have programs for what we call low, moderate income members. And so that's why they ask on this calculator for your household income, because there are higher tax credits for based on your income. So like you could get up to 8,000 versus 2,000 for the heat pump that does both heating and cooling. So look at that calculator. And a lot of that is coming in 2023, although there's a couple things now.
yep. Thanks. We got another question here. I guess this one's for Tim. Can you discuss more the venting requirements for a heat pump water heater? Can they be put in the utility room and not be vented? Sorry,
Tim, you're muted.
Tim, you're muted.
All right, that was a great question. Thanks for the catch on that one. As long as it has access to, close to 700 cubic feet. Now, can you put it in a closet? Yes, provided you have some venting, like a louvered door. If you have like partially louvered, as long as you have 3/4 inch at the bottom, you could do it that way. In fact, I would say over 90 to 95% of water heaters aren't vented. Okay, they have a way of getting air to those units. And some people, when they do vent them, sometimes they bring air to the unit. Some have the air already and they take the exhaust and put it into another conditioned space. That's just a problem. I've had people actually vented out into an attached garage, because attached garages typically don't get 37 degrees. You'll know that when you pull your car in full of snow and it's all melted in the morning, right? So did that answer your question, I hope?
Yeah, I think that's great.
Yeah, I think so.
Good.
And Tim, we're seeing some articles. So this is new construction. So all of this equipment uses like 208, 240, and then what, 30 amp or so? Is that right?
Correct. Now, we just did introduce a 120 volt unit that just hit the market about 3 weeks, maybe a month ago. Can't really speak too much about that at this point, because there are a lot of pilots going on right now that we always try to let third parties determine and provide information, not so much us as a manufacturer, because it's self-promoting. But typically, our recommendation in situations like this, if you're in a warm weather climate, it's probably a good fit. If you're in a colder weather climate, it will fit, but you have to realize what the expectation, you have to have realistic expectations for recovery.
Mm-hmm.
Okay.
So it would be more like somebody like me, a single or 2 people household, that type of thing for the 120, which would be an easy retrofit versus a new build. So, yeah.
Correct. Absolutely correct. And any heat pump water heater manufacturer will tell you is that it has to be sized properly, regardless whether it's the Proterra or the 120 volt version.
Okay, that's great. That's good news.
Great, thanks, Tim. Don't see any other questions here in the Q&A. If there are any last second questions, go ahead and raise your hand. Otherwise, just want to thank everybody for coming today, and thank you, Dave and Tim, for joining us and enlightening us on all this technology for new construction.
Well, thanks for having us.
Thank you, everybody.
Thank you,
Have a
everybody.
great evening
All right, have a great
and
evening.
have a great Labor Day weekend.
All right.
Go Rockies.
Go Rockies. Go
Bye, everybody.
Cardinals.
No.
Bye,
Bye,
all.
everyone.